Okay, welcome to AP 1.8. Okay, so in 1.8, we are going to look into nomenclatures, okay, writing chemical formulas, and at the same time, we are going to understand some key concepts on what is the difference between ionic and covalent compounds and what are oxidation numbers. So, when you look at ionic compounds, the ionic compounds formed between a metal and a non-metal, okay, that is a primary difference. So, a metal gives an electron to a non-metal, and then it is an unequal sharing, usually due to electronegativity difference. The non-metal has high electron density compared to the metal. The ionic compounds usually form lattice structures. So basically, if this is just one metal atom, all the other metals surrounding the lattices are non-metals, and if you see the other one, it is metal. So if you have an X and Y, the X will be surrounded by Y's, and then alternatively that will be an X. So at the end of the structure, you will have either 1:1. All of them will have like Na plus Cl minus one sodium and one chlorine at a ratio of 1:1, or it will have magnesium chloride like 1:2, or aluminum chloride 1:3. But if you have a covalent compound, both of them will be non-metals. Then both of them non-metals, and then it will have an equal sharing. So this arises because of their equal negativity, that is very close electronegativity values, and they form only individual molecules, and like water molecules. Okay, one water molecule followed by another water molecule. They don't form crystal lattices. So this is what primary understanding when you have covalent, ionic, and covalent. The reason why we have to establish this is to make you understand that there are two different nomenclatures. When you name compounds, there is a separate way to name ionic compounds and a separate way to name covalent compounds. Covalent compounds are very easy to name. So first we are going to look at the ionic compounds. So when you look at the ionic compounds, before we go that, we have to understand what is called as an oxidation number. Oxidation number means it is the amount of electron that can lose or gain. Okay, if you take the first group, lithium, sodium, potassium, rubidium, cesium, francium, all of them, if you look at the electronic configuration for lithium 1:2s1, and for sodium is 1:2s2 2p6 3s1, and potassium ends with 4s1 and 5s1 and 6s1, so on. So if you look at that, they can lose only the last one electron, and they don't want to lose any more electrons from a filled shell. So if you take that, the oxidation number of the first group is always +1. And if you look at oxygen family, the oxygen, sulfur, selenium, tellurium, polonium, all those elements, you will see that they end up with a 2p4, 3p4, 4p4, 5p4, and so on. In this case, they don't want to lose 4 electrons, but they can gain 2 electrons to form 2p6 and 3p6 and so on. So they gain electron. So that is the reason their oxidation numbers are -2. Okay, so the necessity is by filling the shell or completing the octet, they achieve stability. Okay, so that is the need for each and every atom to form bonds. When you look at the periodic table, so when you write when you name a compound, the best thing is to do is to take a periodic table and write down these numbers. Those are obvious oxidation state, like the first group always loses 1 electron. So the oxidation state is +1, and this one is +2, and the boron family +3, carbon family is +4, nitrogen is -3, -2, -1, and 0. This is called as an S block elements because all the periodic, the electronic configuration ends with the S. 1s1, 2s1, 3s1, 4s1, and so on. Here, all the electronic configuration ends with a P. So that is the reason they are called P block elements. So here it is a D. So all the electronic configuration ends with the D subshell. It's called as transition element because it transits between S and P. So it has variable oxidation state because they might have different oxidation states. And F also has various oxidation states because their shells also ends with electrons in the F subshell. So the easiest way is to first write down these numbers +1, +2, +3, +4, -3, -2, -1, 0. And from there we can start. That's the simplest way. We can come back to this D blocks and F block. Usually they won't ask in any AP exam. Usually they will try to give you the names of the compounds. Okay, but it is better to have a very good clear picture about this naming the compounds, because it will help you to understand and have a very strong foundation or fundamentals in chemistry. So if you look at the monoatomic ions, we see that the group 1 metal ions, all of them have the charge of +1, and group 2 has +2, and group 7 has -1. And you have variable oxidation states. Like copper sometimes has 2 plus charge and also +1 charge. Iron has an Fe2 plus and also Fe3 plus. So they have variable oxidation states. Okay, variable oxidation states. So now when to name compounds, how to name compounds? So if the lithium fluoride is given, then what you have to do is the charge of lithium is +1. Okay, lithium is +1 and fluoride is -1. So you write lithium +1 and F -1. And what we follow is called as a crisscross method. Okay, crisscross method means the +1 comes here and the F -1 comes here. So you can ignore the plus and minus, and then you write LiF1, Li1F1. And you can always ignore these 1. It's obvious. And you write lithium fluoride. Okay, so LiF. The calcium, if the calcium iodide, for calcium iodide means calcium is Ca2 plus. Okay, this is a group 2. And iodide is also 1 minus. It is not 2 minus. Okay, it's 1 minus. So it is calcium iodide. So it is calcium is giving 2 iodine, 2 electrons. Okay, that means it needs 2 iodines. So it is going to form calcium iodide, Cai2. Okay, that should be correct one. Now, when you look at magnesium chloride, I'm going to explain what is the real crisscross method is. Okay, magnesium chloride, MgCl2. MgCl2 means obviously the oxidation state of Mg, the 2 is here. So we have to transfer and make sure we have to decipher this as Mg2 plus, and Cl should be -1. Okay, so the answer should be, it should be magnesium chloride. If you go back and look at what it should be, magnesium is nothing but Mg2 plus and chloride is nothing but Cl minus. And if you crisscross, you are going to get back the same thing. What is the meaning of this? The meaning of this is magnesium is giving 2 electrons. That is the reason, that is the definition of Mg2 plus. Mg2 plus means it is losing 2 electrons. But to gain those 2 electrons, there should be 2 chlorines. Okay, so that is the reason we are writing 2 chlorines. So the initial formula is Mg1 and 2 chlorines, so MgCl2. Okay, so this is the understanding. So instead of doing all these things, who is giving and who is gaining, you simply follow what is called as um, the crisscross method. Okay, so you just write down the oxidation state and then move across to the feet, and then you write the final answer. There are polyatomic ions here. Polyatomic ions are 2 types. One is, if you take phosphate, PO4 3 minus, okay, you have both nonmetals. One is phosphorus and another one is oxygen. If you take dichromate, Cr2O7 2 minus, you have one is a metal and one is a non-metal. Chromium is a metal and another is not. It doesn't matter, but you have to know that the polyatomic ions can be made up of both metals and non-metals. And if you look at the formula, potassium dichromate, how to write potassium? Potassium is K plus, dichromate is Cr2O7 2 minus. So I am just bringing the 2, just bringing here to the potassium, and I have, there is only +1, I can bring it down. I can write K2Cr2O7. Okay, I am not using any parenthesis because in this one there is only 1 I have to write. But if I have to write magnesium acetate, magnesium is Mg2 plus and acetate is -1. This 1 can easily come here. But when the 2 comes here, this is coming for the entire thing. So then I have to write a parenthesis and then you have to write a 2. This is very, very important. Okay, you cannot skip parenthesis anywhere. So using parenthesis is very, very important. Okay, you can always avoid number 1. Okay, and when you have D block and F block elements, when you have variable oxidation states, you have to specify by a Roman number. Okay, let's look at the example. Like if I look at iron 2 sulfate, iron is Fe, iron 2 means Fe2 plus, and sulfate is SO4 2 minus. When they have the same thing, I can cancel it out and I write FeSO4. But when I have iron 3 sulfate, iron 3 means Fe3 plus and sulfate is SO4 2 minus. Then 3, when it comes for the entire thing, it has to go under parenthesis and 2 comes here. Then I have to write Fe2 SO4 thrice. Okay. You have to re-watch this video again and have a clear picture about how to do this. And you need a lot of practice in this section. Okay. And no cheat sheet will be given in any of the exam, but you should have a clear picture about how to do this in the class test and exams. And if I have copper sulfate, what is the oxidation state of sulfate? Sulfate should be -2. Since there is no other number, obviously copper should have a charge of +2. So when I write down the name, I should write copper. I should specify the 2 in Roman number 2, okay, and then sulfate. Okay, I have to write that. But if it is copper Cu2SO4, that means the Cu is 2 minus, but the copper should bear a charge of 1. Okay, so it should be copper 1 sulfate. Okay, so these kind of little things are very, very important, and you have to follow that meticulously, right? So if it is only group 1 or group 2, you don't have to specify these Roman numbers. But if you have to, if it is a transition element, if it has a variable oxidation state, you have to specify the oxidation. Now, when you have anions also have several rules here. Okay, if you have sulfate SO4 2 minus, and these are base ions. Okay, sulfate is a base ion. Now sulfite means you have to remove one oxygen, it becomes SO3 2 minus. If it is a chloride, okay, SOClO3 minus, and if it is chloride, it becomes ClO2 minus. You have to remove one more oxygen. And if it is hypochlorite, you have to remove one more oxygen. So you remove 2 oxygens here. If it is a perchlorate, then you have to add one oxygen to the chloride. So ClO3 becomes ClO4 minus. Okay. So but there is no change in charge. Okay. So this is like the simple rules, but you have to remember the rules because it looks really complicated. Add one oxygen, remove one oxygen, and so on. Okay. So this is like a new language. Okay. So when you start doing it, might look complicated, but once you practice with a couple of things, then it becomes very easy. And anion rule number 2, it is sodium carbonate is Na2CO3. If it is sodium bicarbonate, if it is a bi, then you add hydrogen. So that means you have to add NaHCO3. Okay, so as I told you, you need more practice with all these things. Okay, when there is a thio, that means you have to replace oxygen with a sulfur. Okay, thio. Those are key things in the anion rule. So this is all with respect to the naming ionic compounds. In the ionic compounds, as we saw, you have to understand what is the ionic compounds is between a metal and a non-metal, and it is unequal sharing. It forms lattice structures. Okay, it can be in any representation. It can form 1:1, 1:2, and 1:3. And when you write down these things, you have to be very careful. See, when you write carbon and then you write a big O, then it is carbon monoxide. But if you write a carbon and then a small O, this is cobalt. Okay, so this is an element. So you cannot write however you want. And also, when you write the prefixes or suffixes, these numbers cannot be anywhere. The suffixes should be only at the bottom. Okay, the 2 cannot be at the top. Okay, so we have to really follow those numbers. Cannot be anywhere at the top. And you should know the oxidation numbers, the standard oxidation numbers, and there are variable oxidation numbers. And simply use the standard oxidation numbers and do the crisscross and write the final answer or final formula of the chemical formula. And you can use the parenthesis only when there is needed. You can avoid number 1. And then the Roman numeral has to be added for all the transition elements. Okay. So those are the things that we saw in for the ionic compounds. And there are several anion rules, and you need more practice that will help you to when they challenge you for any test or any exam in a classroom setting. But when you have covalent compounds are very, very easy. We know that we have two non-metals. Okay. The non-metals it easily deciphers itself. Let's say that this given as carbon tetrachloride. When it say carbon tetrachloride, carbon is only one, so I am writing carbon. Tetra means four. Okay, you have to memorize this. Mono means one, di means two, tri means three, tetra means four, penta means five, hexa means six, hepta means seven, octa means eight, nano means nine, deca means 10. So carbon, it's not written as monocarbon. If it says carbon, it's obvious it's mono. So carbon tetrachloride, that means four chlorine. So CCl. Yes, it gives SF6. I see that there are both of them are non-metals, both sulfur and fluorine. So that means it's obviously a covalent compound. Then I have to use a covalent nomenclature. So it is a monosulfur. There is only one sulfur. I don't have to specify that. So I write sulfur hexafluoride. There is six fluoride. So I write hexafluoride. Right? Hexafluoride. If it's given P4O10, then I'm going to have four. So 4 is tetra. So tetra phosphorus. And 10 means deca. So I write deca. Tetraphosphorus decaoxide. In all those things, you would have seen that for all the first one, even in the ionic compounds, you see that the cations are written as such. Lithium is written as such. Calcium is written as such. Okay. Magnesium is written as such. But the anions are always added with the word IDE. Fluorine is added with fluoride, iodide, chloride, and so. Okay, the same thing happens here also. In the covalent nomenclature, carbon is written as carbon. The first one, sulfur is sulfur, and phosphorus as phosphorus. But the end one is always written as chloride, fluoride, and oxide, and so on. Okay. In the case of is very simple for a covalent compound. So we don't even if you practice for 10 or 20 of them, then you will be done. But when you look at acids, the same thing. It comes from the anion. If you use a sulfate, you have to name it as ic acid, sulfuric acid. If it use sulfide ion, it is sulfurous acid. Okay. This also gets little bit more complicated with all the acid. But I would suggest that you memorize these 5 strong acids for AP. HCl is hydrochloric acid, H2SO4 is sulfuric, HNO3 is nitric, HClO4 is perchloric, HI is iodic acid. Okay. When the number of oxygen increases, it becomes a very strong acid. Okay, for many reasons that we are going to see only in AP Unit 8. I'm going to explain to you why there is a specific reason for this. But you can easily memorize these 5 acids, which is very strong acid: hydrochloric, sulfuric, nitric, perchloric, and iodic acid. So the rest of them, okay. So not the rest of them, but you have to you have to practice more with the worksheet. Okay, then only it will help you to be very savvy about this nomenclature. Nomenclature is nothing but a new language of chemistry, writing formulas. Okay, only when you know the names, then you will be very confident about chemistry. So I prefer that you take a worksheet and then work on it very studiously, and then um challenge yourself, by which you have very clear picture about this. Okay. Thank you.